Hello friends, welcome to today's class number 4 of WAVE chapter. In the previous class what we discussed? We discussed about the sound wave, the propagation of a sound wave, Newton's formula, Laplace's correction, like this many more things. But today class is very important. Today I'll discuss the very important wave equation. Wave equation we'll discuss, which is maximum time used in class 12th. Maximum time you'll use this equation, that is the wave equation. So today's discussion is wave equation. So first the question comes to mind. What is equation? Equation means relation between the variables is called as equations. You must have written many equations in class 10th, 9th like this in mathematics. What? Linear equation, quadratic equation, the relation between the different variables like x and y. Here is there any variable? Yes. Here many variables are there. So we'll relate those variables. When we relate those variables, then that is called as a wave equation. I think also you have derived one equation just in the previous chapter, simple harmonic motion. You have derived the equation of oscillation, equation of oscillation. You have derived it. So what is the equation of oscillation? So equation of oscillation you have derived it like this. Y is equal to r sine omega t plus or minus phi. You know all the quantities. R is amplitude, omega is angular frequency, phi is the initial phase, y is the displacement of the particle which executes a system. And who are the variables here? One is y, one is t. These two are the variables. There the displacement of the particle varies with time. Displacement increase, decrease, increase, decrease with time that vary. That's why you derive the equation between two variables y and t and you got this equation. You have derived it. I'm not going through this. You have done this in the previous chapter. But in this chapter, but in wave, what's the difference in wave? What more in wave? This is the equation of oscillation. But what more in wave? Obviously more. Why? Because I had told you, wave means oscillation plus, recall, oscillation plus propagation. So oscillation part you have done in the previous class. Then another variable will be added here due to propagation. So what are the different variables in wave now? What are the different variables in wave here? So let's first see what are the different variables when the wave is propagating like this. So this is the wave. When the wave moves in this direction, this is x-axis. The particle oscillates along y-axis. We can say also this is the graph between y and x. So I have told you the wave propagates along x-axis. The particle oscillates along y-axis. I am doing here which wave? Transverse wave equation. It will be easy for you to derive. So wave propagates along x-axis, particle oscillates along y-axis, and everything changes with time. Time that always changes. Nobody can make it constant. Okay. So both changes with time. You see this part you have done. You will see this particle at the origin. This is the origin. I have taken it as origin. Okay. So particle at the origin, it will not be in that position. After some time it will go up, will come down, go up, will come down. You have understood already this one, that the particle execute SSM. The particle execute SSM, simple harmonic motion. The particle will execute. And y varies with time. So y is a function of a time. Y is a function of a time. Y varies with time, which one you have already done in the previous chapter. In simple harmonic motion chapter, you have already done this one. But what extra? Extra is another variable is added here, that is x. because you know many particles when oscillate with a good coordination between them, then the wave form. I had told you in the previous lectures that the particles this first get disturbed and start oscillating. It make the next particle disturb, make the next particle disturb, make the next particle disturb, and the disturbance gradually move from particle to particle, particle to particle, and the particles continuously then they start oscillating, but one after other. Remember this sentence, these words remember. The particles oscillate, that's true, but one after other. Disturbance move from one particle to another particle. So this x also varies with time. You see, x is a function of time which gradually increases. But when y is a function of time, you know y varies with time. How? Sine graph, sinusoidally. Okay, that varies with time. Okay, increase, decrease, harmonic sense. Okay, so that's a harmonic function. Then if we mark y and x, they also dependent on each other. They are also. Again I can write y is a function of x. Y is a function of x. Suppose at this position. At the particular position you mark suppose this position, or you see this position. At this position you see displacement is also varied. At this position, now but suppose at this position particle is at origin, but at this position when x change, particle is at maximum displacement amplitude. When you now x increase, particle is at again zero displacement, means equilibrium line, mean position. When x increase again, particle is where? Particle is here. Particle is not here, particle is here. X increase. But what happens to the particles? At a particular time, if you fix the time constant, how can you make the time constant? How can you make the time constant? Time cannot be constant, but how can you make it? If you just take a picture of the wave, take a photograph of the wave, just like this. This is the photograph of a wave, suppose. When x increase, but y increase, then decrease, then increase negative, then decrease. So y is also a function of x, and y increase, decrease. Also this is which change? Periodic change, harmonic change. This is also harmonic change. It's also harmonic function. So all these three are related with each other. So now it becomes complicated for us to get one equation which will relate x, y and t, and then that equation will be called as wave equation. In SSM we relate only y with t, but in wave we relate y, x and t. Y is oscillation, x is propagation, t is time. All three are dependent on each other. So now let's see how we'll derive this equation. It's very simple, not difficult. Have patience and listen. You suppose consider this particle as origin. This is at the origin. You also take its phase as 0. We start observing when this start oscillating. So its phase is 0. Okay, so this is of 0 phase. No phase it has, 0 phase. And the particles now oscillate. I told you some words, one after other. Okay, particles oscillate like this. So let's consider, let's write the equation of this particle first, which is at the origin. Its value of x is equal to 0. Why I am interested to write the equation of this particle only? Because its value of x, if as it is at origin, its value of x is how much? 0. So let's write the equation of that particle first. That particle equation is y is equal to r sine omega t. If the question comes to your mind, sir, what about x there? X is 0. So that's why where the x was there, that x cancel. So that's why I wrote the equation of first this particle. It's easy to write. Okay, y is equal to r sine omega t. No x, because x is 0. Okay, so now again we will consider another particle. Consider this particle P, which is at a distance small x from this particle. I first consider this one because its equation is very easy to write. Then I will write again the equation of another particle only to bring the x. We have to enter x in this equation to get wave equation. Our purpose is how to enter x in this equation. Okay, to get the wave equation. So now come to this particle P. P is oscillating here. P is oscillating here. This is the oscillation line of the P. P oscillates like this in this line. Okay, in this direction P oscillate. P will not change its position like in this direction. It only oscillate here. Let's write the equation of a P. But when I am going to write equation of P comparing with O, tell me. So P leads in phase or P lags in phase with reference to O. P leads in phase or lags in phase. Phase, about phase I have told you in the SHM chapter. If you have not seen, you see the SHM chapter videos. Then come to this phase. First the phase, when any particle which oscillates later, then it lags in phase. Then it lags in phase. So I told you one after other, one after other, one after other. So this oscillating late. So late means it lags or leads. Obviously the answer will come from your side. P lags. P lags in phase. It is lagging O by some phase angle. Because this is a zero phase. I have considered it zero phase for simplification. Okay. So now its phase we have to see how much it lags. But how can you find how much this lags? It's right. It's the path difference or the distance gap between O and P is x. But how much is the phase gap? How much phase it lags? How can you find from this x? It's very simple to find. First simply you see. From this to this, from this point to this point, what is the distance difference? Lambda. Okay, now so. From this to this, the distance difference is lambda. Distance difference is lambda. When distance gap is lambda, when path difference is lambda, then what is the phase difference? 2 pi. The phase difference from this to this is what? 2 pi. Okay, so this to this phase difference is 2 pi. Then path difference is lambda. So when path difference lambda, then phase difference 2 pi. When path difference is x, or you take first 1. When path difference is 1, then phase difference is 2 pi by lambda. When path difference is x, then phase difference is 2 pi by lambda into x. This is the phase difference between this and this particle. Again I am telling to you. So I need the how much phase P lags in comparison to O. I want to get that one. So what I did, I first take from this to this, when distance gap is lambda, then phase difference is 2 pi. We know this is 0 and this is 2 pi. This is pi by 2, this is 0, this is pi by 2, pi, 3 pi by 2, 2 pi. So when lambda, this is 2 pi. When 1, 2 pi by lambda. When x, 2 pi by lambda into x, I just use the unitary method. So how much of phase it lags? So it lags by this much phase, 2 pi by lambda into x. So now let's write the equation for particle P, for P. So y is equal to r sine omega t. But it lags. Lags means which sign I will put? Plus or minus? Minus sign. So minus how much phase it lags? 2 pi by lambda into x. This much phase it lags 2 pi by lambda into x. So I did minus that much. So r sine omega t. But what is 2 pi by lambda? You see the terminology video. Okay, you will get 2 pi by lambda is equal to k. So the angular wave number 2 pi by lambda omega t minus kx. Got the equation of wave? So this is the equation of wave. Very important equation. Many times this equation you will use in class 12th. y is equal to r sine omega t minus kx. But the question comes here. This is not only the equation of a wave. Wave equation can be written also in different form. I consider the particle here. I take the particle, first reference particle at the origin with phase 0. That's why this equation comes. But you can have many equations, many type of equations of the many forms. This equation also can be r sine omega t plus kx. This equation also can be y is equal to r sine minus omega t plus kx. This equation can be y is equal to r sine minus omega t minus kx. This equation can be many types. In different form the equation will come. But one thing you remember here. This is very important, you remember here. So first to analyze this equation. Why this minus sign comes here? The minus sign comes because we consider the particle here and the wave is propagating in this direction. When the wave is propagating along which direction? Positive x-axis. That's why the minus sign comes here. When the wave is propagating along, as the wave is propagating along positive x-axis, that's why minus sign comes here. So when in 12th class this question will come, then nobody will explain you why the minus sign comes, or when the minus sign comes the wave propagates along positive x-axis. But now you better understood here. Why minus sign? Because as the particle is going in this direction, so when you go forward, then the particles will lag. Because they will start the oscillation later. So that's why minus sign is here. Got it? So what I told you? So remember, in which direction the wave propagates, if the question will come in exam, what will do? Remember this concept, that in which direction the wave propagates. So one thing is very important here. If you find either minus here or minus here, these two, minus kx or minus omega t. You can also convert this to this form. Okay, so if minus here or minus here, either minus kx or minus omega t. If either one is minus, then remember the wave propagates along positive x-axis. The wave propagates along positive x-axis, and which variable is there inside the bracket with the sign? That is the direction, that is the axis of a propagation, direction of a propagation. Then plus minus will decide from the sign. As x is here, the wave is propagating along x-axis. But whether positive x or negative x, if minus kx or minus omega t, then the wave is propagating along positive x-axis. But if this situation comes, either both plus or both minus, if you both plus or both minus, then the wave propagates along negative x-axis. If you both plus or both minus, then the wave propagates along negative x-axis. These two negative x-axis and these two positive x-axis. Remember. So hope you write it in your copy. If either one is negative, either minus kx or minus omega t, then the wave is propagating along positive x-axis. If either both positive, if both positive or both negative, then the wave is propagating along negative x-axis. So this is about the direction of a propagation of the wave from the wave equation. But we can again make it more general. We can again make the wave equation more general. What more general? So I consider the phase of this particular at the origin as phi, 0. I take the phase as 0. But if I consider, if I tell no, this particle has some phase at the origin. If this particle has some phase at the origin, then also we have to write. So then the graph will be how? The graph will be like this. The particle starts from here. then the particle has some phase. The particle has already started the oscillation. The particle has already some phase. Okay. So if the particle has some phase, then what happens in this case? In this case, the wave equation y is equal to r sine omega t, then plus or minus kx. This is the general wave equation. Then that phase of that particle is added here, plus or minus phi, because initially the particle has some phase, and this phi naught is called as the initial phase or epoch. E-P-O-C-H, epoch. Okay. So this is the general wave equation. General wave equation y is equal to r sine omega t plus or minus kx, then plus or minus phi naught. Finally, this is the most general wave equation. So now let's move to the velocity. When I tell you about velocity, then what happens here? Two velocities are coming to your mind in wave. One is which velocity? Particle velocity. You see, this is the wave. This is the wave. Then what happens here? Particle oscillate in this direction, y-axis. Wave propagated along x-axis. One is particle velocity. Remaining in its position it will do SSM, particle velocity. So particle velocity, how can we get particle velocity? dy by dt if I do differentiation of y. When the wave is propagating along x-axis, which gradually always increases. So how can you get wave velocity, or that's also called as a phase velocity, that is dx by dt. Differentiation of x is equal to wave velocity, but differentiation of y is equal to particle velocity, where the particle velocity increase, decrease, becomes zero, becomes negative, becomes positive. Like this you have done in SHM, like the SHM wave, the SHM velocity. But here wave velocity always increases, and that's constant in a particular medium. In a particular medium, that remains constant. When medium change, then different thing happens. Okay. So let's find the relation between these two velocities. As in wave, there are two velocities, but in SHM there is no such problem. There is only one velocity, that is the particle velocity. Let's find the relation. It's very easy. So wave equation, let's write y is equal to r sine omega t minus kx. Means I choose the wave in which axis? Obviously in positive x-axis. Direction of propagation positive x-axis, and I have considered the initial phase of the particle at the origin as 0. I have not taken any initial phase here for simplification. Okay. How can we get particle velocity? You differentiate it. But when we do particle velocity, means for one particle we will see the velocity, means we fix the particle. Suppose this origin particle, means particle is fixed now, at the origin I will see. Okay, or at any position, I can see also at this position. If I see at this position, means now for this particle x is equal to constant. For this particle x is equal to constant, because I will see only the particle which is at point P, that oscillate like this, that oscillate in this direction. Only I will consider the particle P, means x is constant now. Okay, so dy by dt. So let's do the differentiation. R sine omega t minus kx. What is the differentiation? Cos omega t minus kx. Then sine differentiation is cos. Then I have to differentiate inside the bracket according to chain rule of differentiation. Okay, I have to do the difference inside the bracket. When you do differentiation of omega t, you are getting omega. And kx differentiation, it will be 0. Why? Because x is constant. I have considered only one particle, so its difference is 0. So only omega. So now this is equation number 1. Let's write Vp is equal to r omega cos omega t minus kx. Equation number 1. Again do the differentiation of this equation, but with respect to x. Differentiate with respect to x. When I do differentiation with respect to x, you make the time constant. How can you make time constant? Just before I told you, take a picture of the wave. When I take a photograph of the wave, means time becomes constant. Every photograph has a constant time. Okay, so time becomes constant. But here with x, particle displacement varies. Just before I explained, when we move forward, x increase, but particle displacement increase, then decrease. Like this, it varies. So here I had made time as constant. Okay, at a particular time what happens? So now differentiate it. It become r. Sine differentiation is again cos omega t minus kx. Then inside the bracket we have to do differentiation according to chain rule. Omega t differentiation is 0 because I told you time constant. Okay, at a particular time. So this is 0. Only kx differentiation is minus k. Equation number 2. Now divide both the equations. If we divide both the equations, Vp by dy by dx, Vp by dy by dx, r cancel, cos cancel. What remains you see here? Minus omega by k. But what is this omega by k? Just recall, what is this omega by k? What is this? This is wave velocity or called as phase velocity omega by k. So implies that Vp by dy by dx is equal to this is the wave velocity minus p. So it implies that I can write V, I can write here Vp. Vp is equal to minus V dy by dx. Minus V dy by dx. Vp, then, okay, this is correct, minus dy by dx. This is the relation between particle velocity and phase velocity. Okay, so we got the relation. Then I am going to tell you another important part of this, that is the boundary condition. But what do you mean by boundary condition? Boundary condition, this is important information you should know to proceed further. What do you mean by this boundary condition? That means when one wave is propagating, gets reflected from a rigid boundary. But the question comes to your mind, it's a rigid boundary you can't able to understand. Okay, I am telling to you, this is a string. You just make it tight on a support. You take a rod or something, just to tight it there. Okay, this is the string, is just tight there. Okay, it's tight, this is string. And you send a small disturbance, suppose you send. After some time you will see the disturbance will be at this position, will be at the end. Now you see after some time the disturbance will be here. Suppose the crest, it becomes crest row, like this the wave propagate. Suppose at the end the crest now touch the rigid boundary. This is the rigid boundary where it is now tight. Okay, when it touches the rigid boundary, it gets reflected from there. When it gets reflected, then what you will get from there? You will get when crest touch, then the trough starts from there. And after some time, you will see the situation like this. This is the trough starts from there. So, what is the important line you will write? When one wave gets reflected from a rigid boundary, then what is the phase difference between incident wave and the reflected wave? This is the incident, this is the reflected. Incident wave crest touch, then trough start. What is the phase change? How much? Pi. Phase change is pi. So remember this one, out of phase. When one wave strikes on a rigid boundary, it gets reflected. The reflected wave is of phase pi difference than that of the incident wave. Or there is a phase change of a pi between the incident and the reflected wave. Rigid boundary. But what happens when it gets reflected from open boundary? Now comes to open boundary. Okay. So when open boundary it gets reflected, make it summarize here. Rigid boundary, so phase change pi. Phase pi change. Okay. Then open boundary. Let's see what happens. But what do you mean by open boundary? Open boundary means you suppose take, this is a rod. Then you tie one ring here. Okay, this is the ring which can move on this rod without any friction. Assume, okay, the ring moves on this rod without any friction, and with the ring now, the string is attached. And in this case, what happens when you send one crest? The crest is going like this. This is the ring. The ring is here. This is the ring. Okay. Here is also ring. Here is also ring. Here is also ring. Okay. So when the crest moves and the crest at last touch it, then what comes from there? What comes from there? Also the crest return back. This incident. Also the crest return back. Also again the crest return back from there. Means, is there any phase change? No phase change. Remember, on open boundary, no phase change. When the wave gets reflected from open boundary. Okay? Then next one. What happens? Suppose one thin rod is here. Then to that thin rod, one thick rod is connected. This is a thick rod. Thin string, thick string. Or you can take a rod. If you send one wave, now wave is propagating. When the wave propagates, then here is a boundary, because now nature changes. This is thin, this is thick. Here is a boundary. Boundary means what? I forgot to tell you, boundary means what? Boundary means the separation of two medium. The interface of two medium is called as a boundary. Air touch the water surface. Then where the air touch the water surface, that is not well defined. A part of air and a part of water is considered. The separation of air and water. Okay, so that's called as a boundary. Here also this is called boundary. If this is boundary, one wave propagate. When the wave touch here, a part of wave gets reflected and a part of wave gets refracted. Here. But what happens to the reflected wave? What happens to the reflected wave? Reflected wave, as it is a rigid boundary. So reflected wave, phase change happens. Phase change, how much? Pi. But what happens to refracted wave? Refracted wave pass to the other string, to the thicker string. Refracted wave, no phase change. No phase change, but speed change. Because it becomes another medium, it becomes thick. So speed change, you know, when wave gets refracted, the refraction is because of change of speed. Speed change, we need to go to the other medium, but no change in phase in the refracted wave. So these are the boundary conditions I also summarized here. Again, I am telling to you, when wave incident and gets reflected from a rigid support, phase change is pi. When wave incident and reflected from an open boundary, then there is no phase change. Okay. Then when the wave gets reflected from two separation of two medium like this, okay, then the reflected wave has phase change pi, and the refracted wave no phase change but speed changes when go to other medium. So today we discussed the very important thing, that's the wave equation. But what questions will come in exam basically from this wave equation? So one important question we'll do, which always comes in exam. Actually, I will do one question of class 12th, because in class 12th you will face the same question. What question? Question is like this. Equation is given y is equal to 3.1 sine 314t plus 1.8 x. Equation is written like this. Okay, the equation is written like this. This must be meter, means in SI unit. What questions will come in exam? First question will come. Question 1. What is the first bit? What is the direction of propagation? Direction of propagation. First question. Second bit. What is lambda? Find lambda. Also find the frequency. Then third, very simple, find amplitude. Find amplitude. So these questions will be asked. Again, many more bits will be attached in class 12th. But this much is the fundamental. I'm writing one question of class 12th from electromagnetic wave chapter. This is the question from NCT book. You are doing the question of class 12th in class 11th. You see how much is there is the relation. Okay. So let's do the answer of this first question. First you do try to do this. You compare this wave equation with y is equal to r sine omega t plus or minus kx. Then use the formula and try to solve it. Pause the video here. First you do. Then after that you play the video and see whether you are correct or wrong. This increases your creativity. I hope you pause the video. Okay. See. Hope you completed. Now see what's the answer. Bit 1. Direction of propagation. I told you here plus. If both are positive, wave is propagating along negative which axis? What is there inside the bracket? Inside the bracket if sign there is x. So negative x axis. If here it would have z. Suppose it would have z, then the answer will be negative z axis. Okay, not like this. What is inside the bracket? That is the direction of the propagation of wave, negative x-axis. Then second, what is lambda? I told you compare this equation with this equation, y is equal to r sine omega t plus or minus kx. In place of k, what is here? 1.8. So k is equal to 1.8. But you know k is equal to 2 pi by lambda is equal to 1.8. So lambda is equal to 2 pi by 1.8. This much meter. Because here meter I have written, so SI unit meter. Okay. Then another one is frequency. How can you find frequency? You see this is omega, and you see omega in place of omega 314 is written. So omega, I am doing it here. Omega is equal to 314. So omega is 2 pi nu is equal to 314. Then nu is equal to 314 by 2 pi, and you can also solve it. 2 into 3.141. Then I think it is coming 50 hertz. So nu is coming 50 hertz. Got it? Then third bit is the amplitude. Amplitude is very simple. What is the amplitude? It's r is the amplitude. This is 3.1. So r is the amplitude is 3.1 meter. 3.1 meter. Okay, 3.1 meter. This is the amplitude. So this type of question will come in exam. Different. This equation will be given and these parts will be asked in the exam to find out. Hope you understand what is wave equation and what type of questions generally comes in exam. Very important question. Thank you.